Good afternoon, everyone. Welcome to the week fourth of this lecture on principle of communication system. So this lecture is the audio session. We'll solve some of the important questions based on the whatever videos are available on the NPTEL portal for the week four of this course. So the first question is, and also this video will be recorded and uploaded on YouTube, and the link will be shared in the NPTEL. First question is the modulation technique in the signal xt is equal to AC 1 plus KAMT cos 2 pi FCT is. So basically, this signal is AM signal. So the representation of AM signal is given as AC 1 plus K cos of 2 pi FCT. So here this is a message signal. So this can be written as AC cos 2 pi FCT. So this is our carrier signal plus AC KA MT cos 2 pi FCT. And this is modulated signal. And here, so the equation given in the question xt is of like ordinary amplitude modulation signal, because in this both the side bands are present. So when we do the frequency like spectrum analysis after the modulation, we will get the signal as like this. This was taught in the last tutorial session also. So the one component of the signal will be present at fc and another at minus of fc, and there is a carrier also will be present at both the frequency, and this is USB, and this will be lower sideband. Here this is lower sideband and this side is the upper sideband. So this is the representation of AM ordinary AM signal. So option A is the correct answer for this question. So now we'll move on to the next question, that is, given the square law, like in this question, the output voltage V2T of non-linear device can be expressed in the terms of input voltage V1T. So V2T is given as A1 V1T plus A2 V1 square T. So here A1 and A2 are the constants, and the input signal is V1T, and V1T is given as AC cos of 2 pi FCT plus MT, where MT is the message signal of bandwidth omega. So bandwidth of message signal is given as omega or W, and AC cos 2 pi FCT is the carrier wave. So carrier wave CT is equal to AC cos of 2 pi FCT. So now it is asking the output V2T is fed as input to a filter tuned to FC. What is the amplitude sensitivity K of the AM signal thus generated with the carrier frequency FC? So for this question, so now we will write the equation of V2T. So V2T is equal to A1 V1T plus A2 V1 square of T. So now we'll substitute the value of V1. So we'll get A1 AC cos 2 pi FCT plus MT plus A2, and V1 is AC cos 2 pi FCT plus MT, and the whole is squared because A2 V1 is squared. So now, so this can be written as A1 AC cos 2 pi FCT plus A1 MT plus A2 AC squared cos of squared 2 pi FCT plus A2 M squared T, and then plus 2A2 MT AC cos 2 pi FCT. So this is the complete equation. So here we can write as A1 AC. Now we'll take the common. So this term I have forgotten here. So let's write this also. A1, no, it's written. So now A1 AC if we take common, so here it will be 1, and cos 2 pi FCT also will take common. Like from this term, and where is another cos 2 pi FCT term? Here this term. So if you take A1 AC common, and this will become 1, and this will become 2A2 by A1 MT, and cos 2 pi FCT also is taken as common. So this is for the first and last term. Now plus A1 MT plus A2 M square T plus A2 AC square cos of 2 pi FCT. So now here you can see the first term is the kind of AM signal, and here it is the carrier frequency is FC. So this is the carrier frequency FC that is required in this question, and this remaining term will be filtered out. So what we will get now, what is asking in the question, that is asking amplitude sensitivity. So this is the amplitude sensitivity for the AM signal which is centered at FC. So the answer will be Ka is equal to, that is amplitude sensitivity, to A2 by A1. So in this question, option D is the correct answer. So we'll move on to the next question. So the next question they are asking is it is related to the power of double sideband suppressed carrier. So the signal is given for DSB-SC. So the signal is given as xt is equal to 4 cos 4 pi t cos of 6000 pi t. First we will see how do we represent the double sideband suppressed carrier. So let's suppose message signal is MT and carrier signal is CT. So then general expression of double sideband suppressed carrier signal will be equal to MTCT. The message signal is here MT and carrier signal will be AC cos 2 pi FCT. So this is the signal, and when you do the spectrum analysis, this time the carrier is suppressed, so only upper sideband and lower sideband will be there, and there will be no component at the frequency Fc and minus Fc. So this is USB, this is USB, sorry, that side is LSB here, and here this is LSB, and this is USB. So now power is, total power will be power of sideband only. So that is equal to power of USB plus power of LSB. So we can also write for DSB SC signal, here this equation we will derive more. So this we can write as AC, and let's suppose MT is equal to, here MT is equal to AM cos of 2 pi FMT. So we will write here AC AM cos of 2 pi FMT cos of 2 pi FCT. So now this is cos A cos B. So we can write this as AC AM by 2 cos of 2 pi FC plus FM into T plus AC AM by 2 cos of 2 pi FC minus FM into T. So this FC minus FM term is our lower sideband, and this is upper sideband. So total power PT, so power of USB, how much it will be? It will be AC squared AM squared by 2 into 4, that is 8, plus AC squared AM squared by 8, because power of USB plus power of LSB. So this will become AC squared AM squared by 4. So in this question, it is given 4 cos 4 pi t and cos of 6000 pi t. So this 4 is the value of AC AM. Okay. So the answer will be 4 square AC AM square divided by 4. So this is equal to AC AM square by 4. So answer will be here 4. So the correct option is the option A for this question. So now we will see question number 4. Like in this question, it is given that, just give me a time. Okay. So in this question, it is given that message signal MT and carrier frequency FC, and the XT is given as AC MT cos of 2 pi FCT. So this is termed as, just now we have studied AC MT cos of 2 pi FCT. This is double sideband suppressed carrier signal. So Option A is the correct answer for this question. So next question is they are asking the frequency response of Hilbert function. So in this question, the options given are minus j signum of f and then j signum of f. So the correct answer is option A only, that is minus of j signum of f. So now the question number 6, the power of DSB's SC signal xt is given as 2 of cos of 2 pi t cos of 2000 pi. So basically DSB SC signal is given as AC AM cos of 2 pi FMT cos of 2 pi FC. So this AC and AM is 2 and total power we have already studied AC AM squared. Here just we have studied the formula divided by 4. So it is equal to 2 square divided by 4. So 4 by 4 is option 1. So the correct answer is option D. So now the next question is, consider a message signal with a spectrum band limited to FM and carrier frequency FC. The corresponding single sideband modulated signal with upper sideband occupies the spectrum. So the single sideband, like S of, we'll write the equation of all three signals, then it will be more easier for us. The first one we studied is the AM signal. So it have, the equation is given as 1 plus k mt cos of 2 pi fct. So this signal have carrier, upper sideband and lower sideband. The next we studied is DSB signal. So the equation is given as AC mt cos of 2 pi fct. So this signal have only USB LSB. So the carrier is not present in the DSB signal. So this, the extra power which is required to transmit, that is the carrier power, is not required. So this is the advantage of DSB signal. Now SSB signal. So this is given as AC AM by 2 cos of 2 pi FC. This can be plus minus FM into T, because this will be either USB or either LSB. So if plus signal is there, then only USB component is present. If minus signal is there, then only LSB component is present. Okay. So now they are asking in this question, for upper sideband. For upper sideband, if it is plus, then we can write this as AC AM by 2 cos of 2 pi FCT cos of 2 pi FMT minus AC AM by 2 sine of 2 pi FCT sine of 2 pi FM. Okay. So here, if it is plus, now then it will become LSB because cos of 2 pi c minus FMT, then it will come plus sign. If it is minus, then it will be USB. So in this question, it is asking which upper sideband occupies the spectrum. Okay. So for upper sideband to occupy the spectrum, that will be FC plus FM. Okay. And another will be minus FC minus of FM. So let's draw the spectrum analysis. This is 0. Upper sideband will be this. So this is FC and this will be FC plus FM. The negative side, upper sideband will be this. This is minus FC. So this will be minus FC minus of FM. Okay. So the correct answer is minus FC minus FM2 minus FC. So this is correct. This is also correct. Next part is FC to FC plus FM. So this is only correct. This is wrong. So option B is the correct answer for this question. Now consider the message signal MT is given as cos of 500 pi t. Okay. The single sideband modulated signal with lower sideband corresponding to carrier frequency Fc is equal to 10 kilohertz. So the single sideband signal is given as AC AM by 2 cos of 2 pi Fc minus FM t. Okay. So this signal will become, and also when the SSB modulated with LSB like lower sideband, so we can write this as lower sideband is equal to MT of cos of 2 pi FCT plus Hilbert transform of MT into sine of 2 pi FCT. So this will become MT is 500 cos 500 pi t cos of 2 pi FCT. FC is 10 kilohertz. So that will be 2 into 10, that is 20 kilohertz. So that will be 20,000 cos of 20,000 pi t plus sine of 500 pi t into sine of 2000 pi t. So it is just like the above equation. Here you can see only the plus sign will come for LSB. Okay. So ACAM by 2, that is equal to 1 here, cos of 500 pi t, cos of 20,000 pi t, and again minus. So minus will be for USB. Here it is LSB. So it will be plus sine of 500 pi t, sine of 20,000 pi t. Okay. So this equation will be cos of 2000 20,000 minus 20,000 pi t minus 500 pi t. We can write like this, and also here you can see that cos of 2 pi fc minus fm of t. So this is equal to cos of 2 pi fc minus fm of t. So fc is 20,000, fm is 500. So for this question, like fc is 10,000 and fm is 250 because this is 2 pi fm t. So fm will be equal to 250. Okay. So here you can directly substitute cos of 2 pi fc is 10,000 minus 250 t. So this will become 9750 into 2. That will be 19,500. Cos of 19,500 pi t. So option B is the correct answer for this question. Now moving on to the ninth question, that is the consider the signal xt is equal to AC cos 2 pi fct plus k of sine 2 pi fmt passed through a square law device with output yt corresponding to given input xt. Yt is equal to x square of t. Now output is passed through a band pass filter with center frequency fc. What is the double sideband suppressed carrier signal? So in this question, yt is given as x square of t and xt is given as AC cos of 2 pi fct plus k of sine 2 pi fmt. Okay, so this will become yt is equal to x square of t. So this will become AC square cos square of 2 pi fct plus k square sine square of 2 pi fmt. So and plus 2 of AC into k cos of 2 pi fct sine of 2 pi fft. So now let's take AC square common here. So this is cos square 2 pi fct. This we can write as 1 plus cos of 4 pi fct divided by 2 because 1 plus cos of 4 pi fct is equal to 2 of cos square 2 pi fct plus k square sine square 2 pi fmt plus 2 ack cos of 2 pi fct sine of 2 pi fmt. So on passing through a band pass filter with center frequency fc, so only component remaining is this component. Okay, other component will be filtered out. So this is the DSB SC signal generated. So now yt after band pass filter, the only component left is 2AC cos of 2 pi fct sine of 2 pi fmt. So the correct answer is option B. Okay. So now we'll move on to the 10th question. Consider the message signal MT is equal to cos 2 pi 200 pi t. Carrier frequency FC is equal to 10 kilohertz and carrier amplitude AC is equal to 10. Modulation is 0.75, that is 75%. What is the efficiency of AM signal? So modulation is also given as K into maximum of MT, that is equal to 0.75. And here M maximum of MT is equal to 1. So this will be Ka into 1 is equal to 0.75. So therefore Ka is equal to 0.75. Now efficiency of AM signal eta is equal to K squared Pm by 1 plus K squared Pm. So K squared will be 0.75 squared. So that is equal to, this is also equal to 4 by, no, 3 by 4. So 9 by 16 Pm. The power of mass signal is half A squared by 2 divided by 1 plus 9 by 16 into 1 by 2. So this is equal to 9 by 32 divided by 1 plus 9 by 32. So this will be equal to 9 by 41. Efficiency is equal to 9 by 41. So this will become 0.2195 and that is equal to 21.95 percentage. So option D is the correct answer for this question. So thank you everyone for watching this tutorial session 4. We'll close the lecture here only today, and in the next session again we'll meet on Saturday, and this video will be uploaded on YouTube and it is recorded, and even the PDF notes will be also shared. The link will be given in NPTEL portal. Thank you. We'll meet next Saturday.